gonna be so great that you're gonna come home with a full bag of knowledge. Okay, thank you guys. Enjoy. And I think before I pass this to Imre and the team, I would like to have a picture of us together. Nggak apa-apa kan ya? But I need to see your smile. Smile dong. Please, engineer, smile. Okay, Mas. Foto dulu ya. Aku di tengah boleh ya? Smile ya semuanya, please smile. Senyum 3 jari yang agak disampul.
Masuk. 2, 3. 1, 2, 3.
Sekali lagi cuma. Once more. Smile. Okay. Thank you. Enjoy the night.
Iya. Coba. Tes lagi.
Yeah. Okay. So let's go to our first speaker. He is already here. He comes all the way from London, so it's a very long flight, I believe. Okay, so give your biggest applause to Mete.
Okay. Harus selesai. Oh ya udah. Ya, at least dia pakai mic juga sih. Iya. Oke. Udah mau coba dulu ambil record dulu. Record aja. Nah. Okay.
All right, does this work? Yes. Can I start? Yeah? Okay. Cool. Hello, everyone. My name is Mete. I'm a developer advocate at Google, based in London, and I'm doing a little tour of Asia. So I started with Ho Chi Minh City and Hanoi, Jakarta, then I'm going to go to Singapore. It's always great to be in Asia for me because if you know anything about London, you know that the weather is horrible. So every time I come to Asia, it's much better weather, so it's great to be here. And I also like to reach out to developers in this part of the world as well, because I don't like to, Google being a US-based company, sometimes we forget that there's a whole world out there. So I think it's very important that we come out of US and Europe and go to other regions and make sure people are up to date with technology. All right, this is my Twitter. So I tweet about things like Kubernetes, Istio, Knative, and general Google Cloud stuff. So if you're interested, feel free to follow me. And just this morning, I open sourced my demo that I'm going to show you on GitHub, along with this presentation. So if you want the presentation and the actual demo itself, feel free to go to GitHub, it's already there. And I also have a little survey. So Knative it's a new serverless framework from Google that's built on top of Kubernetes and Istio. It just came out and we just started talking about it. So I'm trying to understand whether people heard about it and what they think about running serverless on Kubernetes. So I have a survey for 5 questions. So if you have time, you don't have to do it now, but feel free to do it at some other time. It will be useful for us to know. And one last thing before I start. We have a startup program where we help startups with their technology and we help them run on Google Cloud. And we have 3 different startup programs: Start, where you get $3,000, Spark, where you get $20,000, and Surge, if you get $100,000, depending on different criteria. So if you're part of a startup or if you are thinking of doing your own startup, keep this in mind. And we actually have a special link for today. So if you go to this link or if you scan this, then you can get $3,000 for eligible startups. So there's a team that basically will look at your application, and if you're eligible, your startup is eligible, you'll be able to get $3,000 to run on Google Cloud. So I'll just keep this for 10 seconds, and then I'll start with Istio. All right, good. Shall we start? All right. Let me just read one more good. Okay, cool. All right, so first I start my talk with talking about why we even talk about Istio, and let me check time so I don't go over. All right. So why we even need Istio? So I talk about containers, and I talk about Kubernetes, and I talk about why they fall short and why we have Istio. But since this is a Kubernetes meetup, I will go quickly here because I think most of you probably know about containers and most of you know about Kubernetes. So I won't spend too much time, but just briefly, a container gives you a consistent context that you can replicate on your machine or you can replicate in the cloud. That's what containers do. Docker gives you a way to define your dependencies, your environment, and your application in a Docker file. So in this case, it's a very simple example. You're depending on Debian latest, you're installing some packages, you're exposing ports, so you're setting your environment, then you're just running Nginx, you're running your application. So Docker made this possible, it gave us a framework to do this in a consistent way. But containers and Docker by itself is not enough, because when you run in production, you need redundancy, meaning you need multiple containers, so you need to manage them and maintain them. You need to scale up and down depending on the traffic. You need to worry about configuration and secrets. You need to worry about health checks. So how do you even know that your container is healthy? So that's why we have Kubernetes. You all know about Kubernetes. One thing that I'll tell you though, so you can see that Kubernetes it's a Greek word. Those are the Greek letters. But everyone mispronounces Kubernetes. And I know this because I'm originally from Cyprus, where Greek is one of the languages. So the right way of saying Kubernetes is Kubernetes. Kubernetes. Yeah. But Kubernetes came out in the US, and I mean, sorry if there's an American here, but most Americans, they tend to mispronounce foreign things. So they started mispronouncing Kubernetes to Kubernetes, so now we have stuck with the wrong name. So even though Kubernetes, at least you learned something new today. And in a really quick way, so in Kubernetes, what you do is you have your code in a container. You create a template, a pod template, which is usually a single container or multiple containers bundled together. Then you tell Kubernetes what you want to be true. So in this case, we're saying we want 3 replicas. Then Kubernetes looks at them and says, okay, these are my nodes. Let me find the right place to schedule these pods. We'll schedule them, and then we create a service to expose the pods to the outside world. The service will have the stable virtual IP, and then people from outside will get to your service and will get to your pods. So in this world, a microservice ends up becoming your code and a combination of Kubernetes working together, right? Which is great, but it's not enough either, because when you run an app in production, you definitely need logging, right? You need to be able to see what's happening in your application when something is going wrong. You probably need HTTP tracing, so if a call is taking a long time, you want to be able to see where the time is being taken. It would be nice to see dependency visualization, so if you have multiple microservices, who depends on what? That would be nice to see. You definitely need metrics, so like you want your services to emit metrics, and you want to collect them and display them somehow. And there's all these other things that you probably need. Sometimes you can ignore them, and it will be fine for a while, but eventually they will come and bite you, as some of you might know. So that's why we have Istio, right? This is the logo of Istio. So it tries to basically solve this kind of problems, okay? So hopefully this gave you a quick overview of like why we even need Istio. And Istio, it's, as you can see, it's another Greek word, because open source people are obsessed with Greek for some reason. But Istio, it's an open source project that's about managing the traffic of your containers. I mean, it says connecting, secure, managing, monitoring, but basically that it all boils down to, you have your containers that are running, Kubernetes schedules them and make sure that those containers are running, but Kubernetes doesn't do anything for the traffic coming into your container cluster, right? So that's what Istio is trying to do, manage the traffic to your container cluster. So if imagine that you have this simple cluster, container cluster, so you have users talking to the front end, then that front end microservice is talking to pictures and payments and authentication microservices. Authentication microservice is talking to an external database, and then maybe the payments microservice is calling an external payment processor. So imagine you have this. In this scenario, anyone can call anyone, right? So front end is not supposed, for example, the pictures is not supposed to call authentication, but no one is preventing that. Anyone can call anyone. You don't know what kind of traffic is going through here. It can be HTTP or HTTPS. You don't know what the rules are, so it's kind of like an open area. Like even though you have these microservices, like there's not much security in this scenario. Once you install Istio, this is what you get. So in Istio, first of all, you have ingress. So all the traffic coming into your cluster goes through the ingress, and you can set rules on the ingress, what's allowed and what's not allowed. So it's secure at the edge. And then all the traffic that's going out, you can also make it go through what's called an egress. So you can control things here as well. Or if you want something to go directly, you can do that as well. So it's up to you whether you want to allow this or not. And also every pod will get a proxy, right? And then this proxy, it's an envoy proxy that I'll talk about. The traffic basically in the cluster will go through the proxies. So if front end wants to call the pictures microservice, the proxy of the front end will call the proxy of the pictures, so on and so forth. And because the traffic is going through the proxies, a lot of interesting things can happen. Istio can do a lot of interesting things like traffic management and policy rules and stuff like that, right? So that's what Istio does, basically controls the traffic. I don't like to put too much text in a single slide, but this is a single slide with a lot of text. And the reason is, sometimes it's nice to have a single slide that explains what is something. So basically this slide explains what is Istio in a single slide. So it's something that runs on Kubernetes today. It's supposed to be platform agnostic, so they're trying to support on different kinds of platforms. At least that was the intention initially. But so far it hasn't happened yet, right? So far Kubernetes is the main platform that's supported. 1.06 is the latest version, but 1.1 is coming soon. And it gives you first of all observability. So by default, when you install Istio, you get metrics for free. You get a way to query the metrics for free. You get a way to visualize them for free. You get HTTP traces for free, and you get dependency visualization for free. So by just installing this and not changing your application, you get all of these observability features for free, and we'll take a look at them. Your services get strong identities, and they also get mutual authentication. So you can be sure that if a service calls another service, they are mutually authenticated, and you can be sure that it's actually that service is calling this service. And then you get a lot of traffic management features. This is the main part of Istio. So you can dynamically set traffic policies and control how the traffic flows in the system. You can set rules at the ingress and egress level. You can set timeouts. So for example, if you make an HTTP call, you can specify what the timeout should be and how many times it should be retry. And Istio retries that for you, so you don't have to do it in your code. And then you can do complicated things like fault injection and delay, so you can delay your calls for testing and things like that. And yeah, we mentioned the policy enforcement. So this is what Istio is, and we'll go through them now, and I'll hopefully have time to show demos for all of this. So you can install Istio on pure Kubernetes. So if you're running Kubernetes locally, or if you're running Kubernetes on AWS or Azure or anywhere, you can install Istio on top of that. But in Google Cloud, there's something called Istio GKE add-on that makes it really easy to get a Kubernetes cluster with Istio already pre-installed, okay? And that's what I'm going to show now. But you don't have to use this if you're not on Google Cloud. You can install it yourself as well. It's just a little bit more work to install it on your own. So how do you get a Kubernetes cluster? In Google Cloud, you would say gcloud. It's still beta. The Istio add-on is still beta. So you say beta, container class is great, give your cluster a name, then specify your add-on, in this case Istio, then specify the configuration for Istio. So as I mentioned, in Istio, your services can be mutually authenticated. If you want that, you can specify MTLS strict, and this will make sure that your services are mutually authenticated, but you don't have to have that if you don't want to. And then you can specify your Kubernetes cluster. and the machine can serve a cluster, and finally the number of nodes. So by having this single command, you will get Kubernetes cluster with 4 nodes and with Istio installed with mutual authentication. So you have that running, and then after that you need to also set a cluster role binding. This basically enables Istio to manage your cluster, so that when you add Istio add-ons, it will be able to manage it for you, right? So basically just running 2 commands and you have an Istio cluster running. I actually have this running, so let me just show you here. So this is Google Cloud Console, and you can see I already have 2 clusters up and running here, and these are I'll use one of them, I think Hello Istio in my demos. And once, and actually let's see, so here I have, yeah, if you can, please. So what I'm going to do here is that I have. You can look closely. Yeah. Yeah. Is it big enough?
Yeah, it's fine.
It's fine. So I already have. Let's see. Let's move this here. kubectl get pods. Yeah, that's better. Yeah, so I install Istio. So if I do kubectl get pods, and everything, when you install Istio, it goes into a separate namespace called Istio system. So when I do get pods Istio system, I should hopefully, yeah, I see all the Istio pods running. So as you can see, they're all running or completed. And then if I do kubectl get services, then I see all the services of Istio running as well. And the important thing is that this ingress gateway, it has a public IP and a port. This is what we want to use to get into the cluster, right? So because Istio is watching the traffic on this IP and port, so that's what we're going to use to get there. So everything is working. Next, I'm going to talk about the building blocks of Istio, and then we're going to install an app and see what it takes to install the app. So I'll continue from here. All right. So Istio has, as I said, 2 parts. One is the control plane, and the other one is the proxy. So proxy it's called Envoy Proxy. It's a separate open source project that Istio basically utilizes to route the traffic through. So it's the thing that does the work. Most of the features of Istio is implemented at this level, but the control plane, the things in the control plane, they can help the proxy to do its work, basically. So there's Pilot for discovery and config management. So if a proxy wants to talk to another proxy, it will ask Pilot, where is this other proxy, and Pilot will keep track of that. And then if we want to configure the proxies, we'll talk to the Pilot as a user, and the Pilot will take the configuration and push it to proxies. The mixer is all about policy checks and telemetry. So if a proxy wants to make a call to another proxy, it will first check with the mixer, can I make this call? Is there a rule that I should be aware of? And if the mixer says yes, then it will make the call. Otherwise, it won't make the call. And also, the proxies will emit metrics. All those metrics end up in the mixer, and then mixer will use them. We'll use those metrics to store them and display them in places like Grafana. And Citadel is about TLS. So if you want to set mutual TLS, Citadel is the one that will set that up, and it's the one that will issue the certificates and rotate the certificates and all that kind of stuff. So that's what Istio is in a nutshell. Let me show you how you would deploy an app. So first, right, thanks. So first we're going to deploy a simple hello world kind of application. And we need to create a Kubernetes service and deployment as if it's just a regular Kubernetes application. So what we're going to do is we're going to say kubectl apply service v1. By the way, I have this in my tutorial. So in my tutorial, I talk about creating a cluster and then hello Istio. So let me just open this up just to make sure that I don't miss anything. So here I create my application, which is a hello world.net application. Then I create a Docker image out of it. I push it to Docker Hub. And then I create a service-v1 YAML. In this YAML file, I define a deployment for my application. So this deployment basically will create the pods. And then the service will expose this pod on port 8080. So this is the Kubernetes service that we're going to create. So I will just apply the service, and let's take a look what happened. So this created the service and the deployment. But right now, let's see if I have the gateway URL set up. So this is the Istio ingress gateway. If I do this, nothing happens because we haven't exposed this Kubernetes service in Istio yet, right? We need to do that. So that will be the next part of Istio, because you have Kubernetes service, but you need to hook that up to Istio routing, and that's what we're going to do next. So let me just talk about that briefly. So right now there's nothing Istio specific, so we created a Kubernetes service and a deployment. We created a pod, everything is running, but we need to hook this up to Kubernetes routing API. And the routing API, there's a lot of building blocks there, but the main ones are ingress gateway, so that's where the traffic comes in, and I'll show you the pod that was running for ingress gateway. Then you need to create a gateway. A gateway is kind of like the front end to your application, and in the gateway you define, which protocol you want to expose and which port you want to expose. For example, in this case, it's HTTPS and port 443. In our case, it's going to be HTTP and port 80. So once you do that, you allow HTTP traffic into your cluster, but then you need to route the traffic to your Kubernetes service, right? You need to somehow associate that traffic to your Kubernetes service. And you do that with something called virtual service. So in virtual service, you basically do the mapping from the gateway to your Kubernetes service. And then there's also something called destination rule. So if your service has multiple versions, like version 1 and version 2, you can create what's called subsets for those versions. And you can further, once the traffic gets to virtual service, you can further route it to different versions of your service, right? And there's much more than this, but I'm just showing you the main parts: ingress gateway, the main gateway, virtual service, and destination rule. Those are the main things that you usually need to worry about. So let's do this. So what we need to do to define is first, I have the same thing here. We create the gateway. So we create the gateway. It's a YAML file, but the API is Istio. And then we give it a name. We specify the port and the protocol, and we enable it for all the hosts. So everything that's deployed in Istio will be able to use this gateway. So this enables port 80 and HTTP in Istio, and we'll apply this. And the next one is the virtual service. In virtual service, first we need to associate this with the gateway. So we are saying that this is associated with the gateway, and then we need to specify which Kubernetes service this virtual service will map to. So in this case, this host is the actual Kubernetes service that created, right? So by doing that, we're mapping the gateway to the service. So let's do this. I think I can do this one hand. Let's see. kubectl gateway. Oh, maybe not. Apply, right? That's me in the background. So gateway is created, virtual service is created as well. It's created, and now if we go back to our curl command and ping the ingress gateway, and it says hello world. It's not that exciting, but at least we enable traffic to our cluster, right? Okay. So all we did is that we had a hello world application and we deployed it to Kubernetes and then we enabled traffic to it. So there's not much to it now. So at this point you might be wondering, what the hell is with Istio? I can do this hello world on my local application. And you did this with all these virtual services and gateways, what's the point? And so I guess this is the point of Istio now. From this point on, we set up for Istio. Now I'm going to explain the benefits of it. All right, so once you have your Istio running, you can install what's called add-ons. One of them is called Prometheus. Some of you might know Prometheus is an open source project. But basically Prometheus is for metrics. So you can install it by just basically pointing to a YAML file and just saying kubectl apply. And once you do that, you have deployment and a service for it. And then if you look at it, you can see that Prometheus is running. And then once it's installed, then Istio by default emits some metrics. And you can see those metrics from the Prometheus dashboard. Then you can install Grafana, which is another open source project. that will let you visualize those metrics. Again, installing it is very easy. It's pointing to a YAML file. And then once you have that, once you send traffic to your application, because the traffic is going through Istio proxies, they will emit metrics automatically, and you will see those metrics in your dashboard. But this is a key point to understand. You don't change your code, you don't add metrics in your code. You just let Istio edit those metrics for you. So that makes it much easier to add on metrics to your application without changing the code. Then you can install Service Graph, which is another project that will give you the dependencies in your application. So you can see that there's ingress, then it goes to product page, then it goes to reviewers page, so you can see all the dependencies, and this updates in real time, so you can see the requests per second. Then you can install some tracing, like things like Jagger and Zipkin, which is for HTTP tracing. Once you install them, you basically, when a request comes in, you can see how long each request takes, right? So you get these by just pointing to some YAML files and then everything enabled. So let me show that. So I actually installed these already. So if you look at the services, let's see. Yeah, if you look at the Kubernetes services, it's a little bit slow. But if you look at services, you should see like Prometheus and Grafana and all the other ones, hopefully. In the meantime, there you go. So you can see that Grafana is already installed and Prometheus is already installed. What we can do is, let me go to my tutorial. So to visualize the metrics, we need to set port forwarding. So let me just copy this and then go back here. And what I want to do is I want to first send some traffic to my cluster. Where is it? Okay, let's do this one. Yeah, so I'm just sending some traffic to our endpoint, so you can see that we get hello world. And then let's copy this. So I'm going to look at Prometheus first. So let's come here. So I'm setting port forwarding to Prometheus, so I can take a look at it from my machine. And then if you go to Logos 8080, I should add this skill to my CV. I can demo with one hand. So if you open port 880, you can see that Prometheus is already there. And then if you look at some Istio request, so you can see that there's Istio request bytes count. So this is already emitted by Istio, right? I didn't change my code, it's just done by Istio. We can do the same thing with Grafana. Grafana is a little bit nicer to look at. So I'm doing the port forwarding again. As this is being done, let's go back here. Open it up. And then Grafana by default it comes with some dashboards. We'll look at the Istio service dashboard if it opens up. How much time I by the way?
You still have.
Okay. Because I still have a lot to show. Let me know. Yeah, the Wi-Fi is a little bit weak, so let's wait a little bit longer, and if not, then I will show you something else. Oh, broken pipe. Let's try one more time. Okay, this should work now. So now we want to visualize the metrics from Grafana. If you go here, there's Istio service dashboard. And then you can see like the request volume, and then duration, and if you have multiple versions of your app, you'll see like V1 and V2 here. So you get this basically for free by just letting Istio manage your traffic. And the last thing I want to show in here, so the service graph to see your service dependencies. But maybe I can show it here because we don't have that much time. So once you do that, you will basically get your service dependency. So you can see like who's calling what, like this. And then if you install the tracing, then you can look at Jagger or Zipkin and see your services and how long each call is being taken, right? So these are some of the add-ons, not all of them, but some of the add-ons that kind of comes with Istio. All right. Now let's talk about traffic management. So I think traffic management is one of the benefits of main benefits of Istio. So you just got this area and load balancing for services. You can dynamically change requests. So you can dynamically set rules about which requests should go where and enforce them using Istio. You can do failure recovery. So usually when you need to make calls from one service to another service, you need to specify timeouts. And if there's a timeout that happens, you need to retry it, or you need to maybe set circuit breakers, right? So you have to do all of that in your code. But when you're running Istio, you don't have to do that because Istio has all these concepts built in. So you just specify what should happen. For example, if you say, if there's an error, try it 3 times, Istio will try it 3 times before it fault strikes your application code. So you don't have to do this kind of logic in your application. And you can also do fault injection. So you can say, I want my 50% of my traffic to fail with HTTP whatever fault, right? And you can do that. Istio will do that for testing purposes. So, for example, you can say, my service A wants to call service B. So it will make a call to service B. This will go to Envoy. Then Envoy will ask to Pilot, where is service B? Pilot will ask Kubernetes, where is service B? And will find it. But the cool thing is that you might have a rule in Pilot that says, I want to send 99% of the traffic to version 1.5, but 1% to version 2. And behind the scenes, this will happen, but service A won't know about that. Service A will just make a call to service B, but behind the scenes, you're splitting the traffic. So this is kind of cool. The other thing is that you can use user agents. So you can say, if the user agent is Android, send it to this version, but if the user agent is iPhone, send it to that version, which is used for testing. And then, we already talked about this, so your failure handling. So you can set timeouts and retries, and then you can limit the number of concurrent connections and things like that. And finally, fault injection. So if you have timeout 100 milliseconds and you retries 3 between these 2 microservices, and timeout 200 and retries 2 between these microservices, you can actually tell Istio, I want to introduce 5-second delay in 10% of my requests to V1 version of my service. So you can get really specific, and Istio will do that, and you can see what happens. Similarly, you can say, I want 10% of my requests to service V1 to fail with HTTP 400s. So you're simulating like HTTP 400 errors that happens occasionally, and see what happens. This is very useful for testing because I never, whenever I was doing this kind of stuff years ago, I would always try to guess what would happen, but now you can actually test it and write tests around it using Istio. So let's take a look at some of this. Traffic management, yes. So in this part, what I do is that first I create a new version of my application. So I change the Hello World to Hello World V2. Then I push the container image to Docker Hub. Then I create a new deployment for my application, so V2 deployment that's exposed behind the same Kubernetes service. And then I try to hit my gateway URL and see what happens. So let's do this. Right, so let me do CTL. And let's say service V1 and V2. So this defines the new V2 deployment of my service. So as you can see, service unchanged, deployment v1 is unchanged, but we created a new deployment for v2. And then if I do curl, I get v2. If I do another curl, I get v2. Then I get v1, right? Because what's happening is that both of these deployments, they are behind the same service. So when we go, it will basically pick one at random, right? But what if I want to test it out and I want to pin my v2 I want to pin my service to the new version, v2 version. To do that, first you need to create what's called subsets. So let me show you this. So we will need to create a destination rule. So in this destination rule, so it's an Istio API. What we are saying is that this destination rule has name v1 and v2, and it's using labels version v1 and version v2. So we are basically creating two versions and associating those versions with the labels in Kubernetes. So that's how we are making the link. So let's create this first. Destination rule. And now what we need to do is we need to update our virtual service to use that destination. So if you look at this one, so this virtual service, now the only thing that we did here is that we are using the same host. So this is the same Kubernetes service, but we are saying subset v2. So this says use destination rule subset v2. So this pins to the version to our application. So let's do this. And this will update the virtual service. Enter. Okay, good. All right, this is updated, and then if you do the curl again, then you can see that it will always be v2. So we pin to the new version. So you can see that we are changing traffic dynamically, right? We are changing to new versions. We are creating new versions. Everything happens dynamically, which is the power of Istio. Let's see what else I had here. So that's pinned to a new version. Traffic splitting. So let's say you want to test things out, and you want to send 75% of the traffic to v1 and 25% to v2 for testing, right? That becomes really easy in Kubernetes. So what you can do is you can create a virtual service wait. And in this virtual service, you say, I want to create this route rule with this subset v1, and I want it to have weight 75%, and I want this subset v2 to get the weight 25%, right? By just specifying this, we can do that. So let's take a look. Virtual service weights. So I'm again dynamic updating the virtual service, and then if I do curl, we get v2. We should mostly get v1 because that's 75%. See, maybe not quite, but kind of works. The next thing that you can do is fault injection. So what if you want to return HTTP 400 for 50% of the traffic to version 1, right? Again, the way to do that is in virtual service, you create a fault rule that says, I want for the 50% of the traffic, I want to return HTTP status 400, and I want to apply to version v1 for my service. So if we go back here, and do abort. Oops, sorry. And then let's do curl again. Now we got fault. Another curl, another fault. Then hello world. So roughly half of the time it should work, the other half you should get the errors, right? Which is very useful for testing. And finally, the other thing that you can do is you can inject delays in your service. So let's take a look at it here. So if you look at the delay, what I'm doing here is that I'm just saying I want a fixed delay of 5 seconds to 100% of the traffic to the version 1 of my service. So the traffic to version 1 will delay 5 seconds all of it, right? So if you do this, and let's just click this. And if I do curl, now it's like delayed 5 seconds. I can't blame the Wi-Fi anymore. It's it's Istio doing the delay, which is a good thing. This is the only time that the delay is good, I guess, when you're testing. But that's how you do the delays. And I think that's all I have in this part. Let's see if there's anything else. All right. Yeah. All right. Yeah, that's all my talk. So if you want so as I mentioned, the slides and the actual demos, they're all on GitHub. I just open source today for this event, so hopefully you'll find it useful. Yeah, and thanks for listening. I don't know if we have time for questions. We have? Okay, so we have time for questions, so if you have any questions, let me know.
For now.
Okay, thank you, Mete. So now we have the Q&A session. So we have souvenirs for people who ask. Okay, a lot of people asking. Okay, I'll count to 3. The first one. Okay, 1, 2, 3. Yeah. Oh yeah. Okay.
Okay, my name is Asran. I'm really considering using Istio and for our next big project. And there is slightly I don't still understand about Istio.
Okay.
How do we perform like service discovery in Istio, and we are using some kind of gRPC. It's a communication between microservice. How does it perform in Istio? And Istio using some kind of proxy, right?
Right.
How do we communicate between those proxies?
Okay.
And one more time, we want to use continuous delivery like Cloud Spinnaker that is compatible with Istio.
Okay, well, that's a lot of questions.
Sorry, thank you.
Yeah. So first of all, what was the first one?
Yeah. So, let me confirm. There are 4 questions.
Yes.
First is how Istio performs service discovery. That's the first question.
Okay, let me answer that one by one.
Okay.
Service discovery, it relies on Kubernetes service discovery. So basically, whatever the mechanism is in Kubernetes, it will ask Kubernetes for service discovery. There's nothing special in Istio for that.
Okay. Next is how about gRPC?
Yeah, gRPC is supported in Istio. Yeah. So that should work.
And how about if we use continuous delivery like Cloud Spinnaker?
Spinnaker. I mean, there's nothing special about Istio when it comes to like Kubernetes. It's just certain pods that run for Istio under Istio system namespace, right?
Yes.
So you can so in Spinnaker you can install Kubernetes and you can install pods. So it will be the same thing. Like there is nothing special about Istio.
There is nothing much different.
No, it's basically just more pods under the Istio system that makes Istio work. But that's it really. Like other than that, there's nothing special about it from the CI/CD perspective. And there was one more.
It is all? Okay, that's
That's
all.
it?
Yeah. This is the souvenir. Okay, for the next question, Giri will see and pick who is the fastest. Okay, I will close my eyes. 1, 2, 3. Which one, Giri? Mas Baju Giri ya, Bu? Mas kotak kok. Kotak-kotak. Oke. Ya.
Okay, my name is Dan. So, I sometimes when it comes to using Kubernetes and having implementing service discovery or traffic management, I'm kind of confused between using service mesh or IPv gateway. So, would you enlighten us whether these two approaches can actually complement each other, or do we have to choose one or the other?
Yeah, I think so. API gateways and Istio, they will eventually work together. Because, for example, there's something called Apigee from Google, which is an API gateway, and it's doing some integration features with Istio. So if you have Apigee and if you have Kubernetes and Istio, then they kind of integrate together and work together. So I think API gateway is different than what Istio is providing. Istio is more about managing the traffic once the traffic is in your service mesh. And API gateway is more about how do you get outside traffic into your cluster, right? So they will, I think, eventually merge at the edge layer. So you have the API gateway at the outside layer. Then after that, will hand traffic to Istio gateway, and then from then on, will get into your cluster, right? So that integration today is kind of like not there. Like you have to set things up yourself somehow. But I know at least for Apigee, because it's from Google, they're doing integration work with Istio, and I'm sure there will be more going forward. So these two things, even though they're separate, they will eventually work together to make it simpler for people.
Yeah. Okay, this is Sunil. Yeah, the last question for this session, Imre will pick who gets to ask the question. Okay, again, one more time. 1, 2, 3.
Mas Afan.
Mas Afan. Nepotisme janjian. Monggo Mas Afan.
Hello, I'm want to ask about how Istio compared to other solution for the because I work in IT infrastructure, because comparing the Istio when I see it as a proxy, right? How do you compare it with other proxy like F5 or the old proxy like F5 or the new proxy like Nginx or Cetra, and also the other networking or security system that usually deploy in the infrastructure? How do you compare Istio to that technology?
Yes, I mean, it's hard to do a one-to-one comparison because I don't, for example, F5, I used it like 5-6 years ago at very, very basic level, you know, so I don't know what happened since then. The Nginx, for example, there's a project where instead of using Envoy proxy, you can actually use Nginx proxy. So they're trying to kind of integrate with Istio. So what my guess, and this is just my guess, is that all these like complementary technologies, they will either kind of merge into Istio as features, or they will somehow integrate so you can use them together. But you're right, like it's a messy landscape because all these tools, they're doing bits and pieces of things, and maybe this tool does one thing that you want, but Istio does some other things that you want, and how do you integrate them, and which one do you use when? It's an open question right now. I think that landscape is still shaping up. So just like with container and Kubernetes, how it shaped up, and you know, when Kubernetes first came out, there was a question of what should I use? Should I use Kubernetes for containers, or should I use Docker Swarm, or should I use Mesos or something? But then eventually Kubernetes kind of won, and it's kind of the most popular now. I think in the same way, Istio will maybe move in that direction, or maybe something else will come along and it will perform better and it will dominate this landscape. But either way, I think there's the consolidation of all the technologies into bigger open source projects, and whether this happens with Istio or something else, we'll see.
Okay. That's all I think. But if you guys still have more questions for Mete or Dr. Imre, just stay in the room. We will have a hallway session after the whole session.
Yeah.
Okay. Thank you, Mete. Give
Thank you.
applause for Mete. Yeah. So now, if Mete was speaking in English, now we are switching to Imre. Imre will present this in Spanish. Yeah. Okay. Please welcome our second speaker, Imre Nagi.
today I'm going to present about how we're running Istio in Traveloka Data production. It's not specific about Traveloka.com product that you see every day when you open our website, but it's more like our implementation in the data team. So currently in Traveloka, especially in data team, we already running Kubernetes load for about almost 2 years, and then we just tried Istio since 6 months ago, and then I will show you how we run it, how we maintain it, and how the result that we got. Okay, I think for the full of this presentation, I'm not going to speak totally in English because I'll try to switch because maybe some people will be able to understand more about what I'm going to say. Introduce myself, my name is Imre, Imre Nagi, you can call me Imre. I'm right now is software engineering in Traveloka Data. So this is my cartoon that was took about 2 years ago. And then I'm also the community leader, and I'm also one of the Jakarta Kubernetes organizer. So the agenda today, we are going to talk about 4 things: Kubernetes in Traveloka, Istio, and how we run Istio in Traveloka, and lesson learned that we got for the last 6 months. Okay, so kita mulai gimana Kubernetes di Traveloka. Jadi long story short, as I said, we have run the load for 2 years in Kubernetes, not Istio, and then multiple teams in Traveloka Data already use it, and they run different type of loads, something like API, and then visualization, dashboard, GPU, and machine learning, and so on. And right now, at least we have thousands of requests per second. I cannot say more detail, but we have huge load that run in Traveloka Data. And then after we use Kubernetes for the last 2 years, what we got is we have something like up to 60% cost optimization by tuning up the auto scaling and by tuning up the CPU utilization. So we got about 60% cost cut. It's pretty nice. And then, as you can see here, this is how we split the load for every team. So in here, every team in Traveloka Data will have their own namespace. So team A will have namespace A, team B will have namespace B, and so on. And for each team, they will have their Kubernetes ingress. And then this is what we have right now in staging in production. So in our staging in production, we have same config, so that if something bad happens in production, we can debug it easily in staging and then run production deployment to fix it. And everything is just working fine until at least one team try to separate their load into smaller service that we call microservices. Why? You can see here, we have right now dependency between services. So this service A try to talk to service B, and service A talk to another services, and the communication between them are using gRPC. And also, right now we have in our Kubernetes several hosts like Team A, the Traveloka.com, Team A, API, Traveloka.com, and so on. And this ingress is connected to our something like GraphQL. And then we also have some machine learning model that runs in Kubernetes. And actually managing all of this is pretty complicated. So why? Because when we have a service, we need to secure the inter-service communication. Usually what we did before is we have something like API key to secure the communication between the services. But when we have so many services, it doesn't work anymore. It doesn't scale. And I'll tell you later how Istio solve this issue. And then we also have unstandardized monitoring approach, because every service in here has their own service admin from our team. And then if they're working with different language, they tend to come up with different type of monitoring style. Someone is using Datadog, someone is using Prometheus, and so on. And then it doesn't has any standard. And then we think that we need to better way to monitor our API in terms of the latency, and then the error rate, the duration, and so on. And then the last thing that becomes a big problem for us is because our services are gRPC. gRPC load balancing doesn't work out of the box in Kubernetes, because when you're running gRPC, you have to do something like client-side load balancing, right? And when you have Kubernetes service, it doesn't work just like HTTP load balancing as usual. So how Istio solve this issue? So basically, Istio will simplify all of this problem. It will help us in managing the service mesh. And what Istio? The 3 good things that we take from Istio is our track management, security, and monitoring. we already see this picture from Mete presentation. So basically, this is a control plane, and this is the service that we have. And these services have their on-site car proxy, which is Envoy proxy. And then this Envoy proxy will try to communicate basically with the control plane, and a pilot will do several stuff like routing the traffic, and then Mr. will try to collect all the metrics and set some traffic policy, and the Citadel in here will try to generate the TLS certificate for inter-service communication. I'm going to start with the traffic management. So basically in Istio traffic management, what we can do is we can do A/B tests, because as you can see here, when we have traffic away, when you set traffic service A to have 50% traffic, service B with 50% traffic, you can do something like A/B test. But if you don't want to exactly split the traffic equally, what you can do is you can run something like canary. You can set one service to have 1% and another service to have 99%. And other good stuff that's been explained, we can set timeout, retries, and circuit breakers, and so on, without changing the code. And that's the good thing. So all of our developers doesn't need to make their own monitoring implementation, something like failure handling and in their code, so they don't need it anymore. And then this is how Istio split the traffic. So if you have this service A with service B, service A basically is trying to communicate with service B. And if you want to split the traffic, let's say service A want to call a current version of service B, and the 5% will call the canary version. You can do it easily in Istio as shown by Mete before. And if you want to split the traffic based in its content, you can do the same. You can say that if the HTTP request has something like HTTP header with Android, that request will go to specific service, and then if it has iPhone in the HTTP request header, it will go to canary. I'm not going to talk to take so much time in slide. And this is the Istio mixer. Basically, the Istio mixer is used to collect all of the metrics, and then it collects all of the telemetry data like for monitoring purposes. And then it also has something like access control and resource policy that can help securing the service. And this is the interesting part. So if you can see here, we have Citadel in here. Citadel is the part of Istio which will generate the TLS certificate. So the main task of Citadel is generating the certificate for inter-service communication. So what Citadel is really doing is it will communicate with the proxy and then give the proxy certificate. And then when this service A wants to communicate with service B through its proxy, it will try to check the certificate generated by the Citadel. So this is how we secure our services. So instead of using API key for all the services, we remove it and we just change it with the TLS provided by the Istio. So this is how we run Istio and Traveloka. So app that is running in Istio right now, we have different type of services. We have Golang and gRPC services. We have some RESTful API, and then we have GraphQL server. And we have some visualization and dashboard to maintain our data, to manage our data. And as you can see here, this is the service mesh that we have. I'm sorry, I need to censor the name. If you can see here, this is the Istio ingress gateway that we have. And then when we have traffic from here, we will go to the services. And then when it needs to call the other services, it will just have this arrow to another services. And then in here we have 1, 2, 3, 4, 5, 6, 7, 8, 9 services. And then the good thing is about this service mesh is if you have Canary and let's say a current version, when you go to this visualization, you will be able to see the Canary as well on this visualization. But I'm not able to show it right now because we don't have live traffic. I mean for this one, not in Traveloka. And then this is the issue that we have in monitoring the service mesh before we use Istio. We have unstandardized monitoring. So as I said before, each service owner has their own approach to do some monitoring stuff. And then the next problem is hard to separate metrics produced by different versions. Like if we have Canary and we have the current version, we don't really see monitoring for every services. By using Istio, we can solve that problem. And then also the third problem that we have also hard to see the client-side metrics. So imagine that we have this service, this service, and then the client of this service is basically the Istio Ingress gateway and the services. If we want to know what is the latency from this one to this one to this one and this one to this one, it will be hard to see if you are not using Istio, because maybe you're gonna need to do some code in the monitoring part, I don't know. But with Istio, it will just come out of the box. You install Istio and then you install the Prometheus, Grafana, and you will get the monitoring. So this is the monitoring dashboard that we have after we are using Istio. So before, right now, actually we also have Datadog, but because actually this project only POC, so we try to run Istio, and then we are not running all of the traffic that we right now in Istio. It's a small portion, but because we are using Istio, and then we decided to try to use Grafana and Prometheus and Jaeger and the other monitoring tools. And by using Istio, what we get from the monitoring part is basically rate metrics. So what is rate? Rate, error, and duration. So it just comes out of the box from Istio. And another reason why we are using Grafana is basically Grafana supported query by regex. And then if you find on internet several monitoring dashboard for Grafana, you can just plug and play it in your cluster. So you don't really need to work on the monitoring. What you can do is just download the plugin and then install it on your Grafana. It's really easy. This is how we did stable and canary monitoring. So currently in Traveloka Data, we call the current version as stable, and the new version called as canary. So if you see here, we can start from this. So there is two lines. The first one is the green one is the canary, and the next one, the yellow one, is the stable. So when we deploy the canary to the cluster, we can really see what is the latency of the stable one and what the latency of the Istio is. And then right here, this is the number of requests. When we start deploying the canary, we will be able to see what is the number of requests coming from the canary, the green one, and because we try to give 10% traffic, and then what and how the traffic in the stable looks like. So you can see immediately without changing anything. And then this is client-side metric, as I said before. This is monitoring from one services. And then when you see this graphic, you will be able directly to see what's the latency from the clients. The first one is, the green one is the first client, and the next one is the red. Sorry, this one, green and yellow. These are two clients that is hitting the monitoring, hitting the service that we are monitoring right now. And if this is the same, this is the latency. You can see there are two monitoring lines in here. This one is from the first client, and this one is from the second client. And this is the next cool thing that you get out of the box from Istio. So this is the distributed tracing. Actually, when you're using Istio, what you get is only tracing from one service to another service. But if you want to know what is the latency for a specific function within a service, you have to do more work. What we did in here is actually, if you can see here, this is two different, this is two same monitoring, but from different perspectives. This is from the service perspective, and this is from the application. So in here, we have function called query, and then it calls another function called payment, and so on. So we can see the breakdown from this one surface, and we can also see the breakdown from the cluster. And this is what we do. This is what we are doing currently with Istio. So each team will have their own dedicated Istio gateway. The reason is because previously when we have shared Istio gateway, when someone breaks the configuration, all the other service that is using it are getting impacted. And we don't want that. So what we did is we created something like dedicated Istio gateway for every team. The benefits that we get is, it's decentralized. So everything can basically maintain their own Istio gateway configuration. And then if something's bad happen on their gateway, it will not impact the other services. The other services will keep running. And then the other benefit that we also get is cost isolation. Because actually when you running the Istio gateway, you actually running another load balancer and it has cost. And if we want to isolate that cost, what we need to do is separate it into different namespace so that the cost is belong to that namespace. Okay, I'm sorry, I talk English from the beginning. Okay, so I think this is the most interesting part. If you see it before when Mete did the presentation, he showed you there are so many configuration YAML manifest that you have to maintain, right? And if we want to scale the team by using Istio, that way really doesn't work because all team members have to know how to use Istio, how to configure Istio, and how to write the manifest and how to maintain it. And what we did in Traveloka Data team is actually we create a Helm chart, we call it DevOps Helm chart template, which basically hide the complexity of the Istio, even the complexity of Kubernetes. So the developer doesn't really know how the Kubernetes manifest look like and how Istio manifest looks like. What they know is only this template. So what we did right now is we're splitting the Helm chart into two different parts. The first one is application Helm chart. So it's related to how we deploy the application, how we limit the resources, and so on. And the second Helm chart is about the infra deployment. What we mean by infra deployment is something like if you want to split the traffic into two services, we're gonna set it by using another Helm chart. Or if you want to set mirroring, we're gonna do this Helm chart. So it handles service routing and security setting. How it looks like. So this one is application Helm chart. So as you can see here, we have the name of the application, and then we have tracks table, and then the environment, and we have the base image, which will be rewrite in by Jenkins when we run the CI/CD, and also the image tag, container port, and then we can also say what protocol that we are using, whether it's HTTP or gRPC. And then we also define the volume. If we have secret, we can also define the secret name and so on. And then we also have volume mount, the name, whether it's read-only or not, the mount. And we can also set the container resource spec in here. So you see that we have request resources, CPU 0.5 memory, and then we have limits with CPU 1, memory 2 gigs. And we can also set the auto-scale configuration. We say that we enable auto-scale, max replica 10, min replica 1, and then the target CPU is about 60%. So developer doesn't really have to know about setting up the Kubernetes manifest or Istio manifest. They just need to learn about it from our documentation and then start deploying application to Istio. And this is how we did the infra Helm chart. I'm going to show you here. So this is if we want to use the shared ingress gateway, we just need to define the Istio ingress gateway, and then we define the host, what the host is, and then basically we give infra at the beginning, and then specify the other things like whether it's gonna be HTTPS and what the gateway, whether we are going to share, whether we are going to use shared ingress gateway or dedicated gateway. And then if we want to protect the services, this is what I was talking about. Let's say for service A to service B, they need to communicate, and when service A wants to communicate with service B needs to have the MTLS set up. So to setting it up is really easy in our case. We just need to say that we are going to enable the Istio mutual, and then we specify the service policy, and then we say that the mode should be permissive or strict. So by setting this up, we will get the MTLS benefit out of this. And this is how to split the traffic to different services. It's almost the same. So, but previously what you see might be a bit different, because in here we remove the subset from the services. So people just know that what the service tag, this one is stable, and then another one is canary, and then we basically split it into stable for 95%, and canary for 5%. And then the other configuration that we have, if you want to, basically if you want to run the test and you don't want your test to run to canary, we also provide a setup. So we basically can say that if the headers is end user with the value Apratama, the service will go directly to canary. Or if they have key something like Agung, if the service, the request will also go to canary. So the canary condition basically override the first rules that we define in here. And this is another interesting thing that we have. So it's also provided by Istio. So if you want to mirror the traffic, so let's say you have 1,000 requests per second running in production, and then you got a problem, but it's difficult to reproduce it. So what you can do is basically you can mirror the traffic from production to staging, or from production to another services, to canary services, and then you can run some testing or some monitoring or some debugging and a lot of stuff in the canary while using the real traffic production. So this is how we do it. We say that mirror enable true, and then we also say what service that will get the traffic from the mirroring. And actually we got problem for this because most of the services that we have is using gRPC. gRPC mirroring in Istio doesn't really work. It still has open bug in Istio. I don't know whether when it will be fixed, but for now that's the issue that we suffer from Istio. But for the HTTP it works. And this is the CI/CD that we have. We are still using Jenkins. What we do is basically when we run deployment to production, we decide which image that we want to deploy, and then in here, and then we pull the image. Basically, this image pooling is used to verify whether the image is accessed. But the image building is actually created in staging deployment, staging CI/CD. And then after we pull the image, we create a secret, Kubernetes secret, and then we run canary deployment in here. In this part, we can decide how much traffic that needs to go to canary. Whether it's gonna be 5%, 10%, 25, 50, or 70. But most of the time we're only using 10. It's bigger than usual because usually canary traffic only for 1%, but it's okay. And after that, in here we have canary to stable trauma verification. It's basically to verify whether this canary deployment can be deployed to production. And it will ask you whether you're gonna deploy it to production or not. If you say yes, and then the stable deployment to production cluster will be executed. So this is how we deploy the application to the production. And if you're wondering how we run the command, actually we are deploying everything with Makefile. So in every project that we have a Makefile for each project, and it will have something like a Make build to build the application, and then Make Docker build to build the Docker image, and so on. And then if you see here, I don't know whether you can really see it, but the first Makefile command that we have is make deploy app. In this part, we are going to deploy the application first, but we are not going to deploy the Istio infra. I mean, for the service routing, the fault injection, and so on. We only deploy the application. And then we say we are going to deploy it into a stable track. And then we also enable the auto scale by overriding the arguments. And then after it's done, and when we see it's, the new pod is created in Kubernetes, we will deploy the infra by running make deploy infra, specifying the environment and the namespace. And then we also, in here, as you can see here, we set the traffic to canary to 0 because this is production deployment. So when we run deployment to production, we need to set the traffic into 0 in canary so that no more traffic goes to canary. And here, after that, we set the traffic weight stable into 100% to make sure that all of the rest of the traffic go to the stable deployment. And then we also set the time up. Usually we use something like 2 minutes or 3 minutes to basically make sure that all of the pod can be deployed around that time. If it's more than that, the deployment will be failed. And we need to figure out what the problem was. And then in here, after we deploy the canary, and then we route the traffic 100% to the production stable, we still need to remove the canary pod. This is what we do. Make delete app name and then type canary. This is how we remove canary from the Kubernetes cluster. So in the end, when we run the production traffic, we don't have any more canary pod running in our cluster. This is the lesson learned. Okay, FYI, we are running open source Istio on GKE. So we are not running Istio provided by GKE. We install everything, we maintain everything. I don't really know the specific reason because DevOps team might know the reason of this. But in our POC, at least for the traffic that we have right now, we can handle up to 800% RPS, request per second. It's too much for this type of application, so we stop it. Actually, we can scale more. Yeah, actually by horizontally scale the pod, but we don't do that because this one is already enough. And then some issue that we found, as I mentioned before, different architecture used in staging and production. And when we had problem, we found some difficulty to debug it and to fix it. So afterwards, we decided to use the same architecture for staging and production. This architecture that I'm talking about is about dedicated Istio gateway. And then gRPC mirroring doesn't work as expected, but HTTP does. And then in Istio, actually, other than NTLS certificate used to securing the service-to-service communication, there is also another security strategy that we can have. So if you have something like authentication provider like Auth0, you can also use JWT token to verify whether the request comes to the Istio service is authenticated or not. We can also do that. But unfortunately, right now in Istio, we cannot use authentication for the real human. So it's going to be complicated. So let's say that you log in by using Google, creating Google email and password, and then it doesn't work in Istio. You have to do something else. What we do right now is we are using another proxy basically to redirect traffic and to make sure the user that is access our service in Istio cluster is authenticated by another provider. So this is just a suggestion. Always run enough load tests. Why? Because we need to fail faster. We don't want to fail in production. If we fail in staging, it's really good, so we can fix it sooner. And then don't forget to tune the auto-scaling config. Don't just give a big number because it will waste so much money. And then if you want to do more work, you need to tune the monitoring. Because when we run in production on the first day, we forgot to set something like the sample for the tracing for the Jaeger. So all of the requests comes to our service, we record everything, and then suddenly monitoring service that we have down. Because basically we cannot save all of monitoring. So what we can do is sampling. Let's say just take 1% of the data and then show it in the monitoring for Jaeger. I think that's all. Traveloka is hiring as usual. I created in Slack by using the emoji. And then any questions? Okay, langsung ini. Okay, yang
Stop
Mas, saya ingin bertanya terkait Istio ini ya. Jadi kan memang sebelumnya Istio ini ramai gitu. Terus tapi saya nggak tahu itu apa. Baru tahu jelasnya sedikit gitu di sini. Cuman saya pengen nanya aja sih, nggak nanya technical terus. Jadi emang sebelumnya tuh kita kan punya Kubernetes cluster, terus kita jalanin service. Berarti masing-masing tim itu memanage service-nya masing-masing dan juga memonitor service-nya masing-masing itu individually ya, kayak dia mereka service tertentu mereka install Grafana sendiri atau apa kan, karena sebenarnya kayak Grafana, Prometheus itu kan bisa diinstal tanpa harus ada Istio kan sebenarnya kan. Jadi emang sebelumnya itu semua sendiri gitu ya kalau yang di kasus di Traveloka itu ya. Jadi Kubernetes cluster, kemudian dibagi beberapa namespace sesuai tim, terus tim masing-masing itu memonitor masing-masing gitu mas ya, kalau yang sebelumnya. Nah, jadi emang positioning sih.
Jawab dulu boleh nggak? Jadi sebenarnya yang dilakukan itu adalah mereka mungkin punya satu tools yang sama kayak Datadog atau Prometheus, tapi matrix yang dimonitor itu beda-beda. Jadi misalnya ada yang cuma monitoring latency doang, tapi ada yang monitoringnya cuma misalnya apa sih, jumlah request error 200, 500, 400 dan segala macam. Tapi ada yang nggak monitor canary atau kayak gitu. Jadi ketika kita pakai Istio, kita standardize semuanya, kita bisa dapat red matrix tadi, red error sama duration, dan kemudian kita bisa dapat yang canary monitoring, client monitoring dan segala macam.
Oke, jadi emang posisinya sebelumnya sebelum ada Istio itu mereka metriknya masing-masing sesuai yang interest mereka. Terus begitu kita implement Istio on the cluster, itu memang Istio yang provide matrixnya, dan jadi kita punya same ini ya gitu.
Yeah, same baseline lah.
Same baseline gitu ya. Ini Istio-nya kan nggak per Istio-nya itu ya di cluster Kubernetes itu kan. Jadi mereka manfaatnya berdasarkan namespace gitu kan.
Yeah.
Oke. Sip. Terus yang pengen saya pasti lagi itu ya saya lebih kayak ini sih Mas, pengen tahu sesuai bayangan saya tuh match gak sebenarnya sama yang dilakukan ini, karena kan kayaknya sih saya nggak tahu yang Istio ini baru yang Traveloka ini saya dapat bayangan jelas gitu terkait. Oke.
Nanti kita bisa ngobrol-ngobrol.
Oke, lebihnya itu aja sih. Saya cuma pengen pastiin itu aja. Makasih Mas.
Ya.
Nama saya Akon dari Project. Pertama kali, makasih ya. Presentasinya menarik, terus juninya juga menarik. Nah, karena udah pakai Istio di Traveloka, mau coba tanya gimana manage sama maintain Istio. Misalnya dengan case yang tadi ada isu gRPC mirroring kan. Kalau dilihat bisa aja kan itu dari endpointnya tuh yang misalnya gimana kalau kita mau upgrade endpoint versionnya. Ini sekarang endpointnya ada asset card dari kontainernya sendiri, terus ada dari front end di depan dari service kita sendiri, di belakang dari service-nya. Gimana tuh bisa maksudnya ada strategi mungkin atau tips and trick untuk manage komponen dari Istio sendiri, belum lagi banyak internal exporter, healthy check segala macam kan.
Jadi pertanyaannya gimana cara maintain Istio version dan segala macam ya, kurang lebih?
Iya, maksudnya lebih ke komponennya. Misalnya sekarang pakai endpoint yang mana service to service udah scatter nih, endpointnya di mana-mana, mau manage versioning dari endpointnya, saya mau fix mirroring gRPC tadi.
Oke. Ya. Jadi selama ini kita baru mulai pakai Istio itu ketika Istio itu versi 1.0.0 dan kita baru sekali update ke Istio 1.0.5. Nah, jadi kita belum banyak pengalaman untuk update endpoint dan segala macam. Tapi yang bisa diceritain adalah dulu awalnya kita jadi di tim data punya satu tim DevOps yang tugasnya untuk manage Kubernetes cluster as whole, yang bikin best practice pakai Kubernetes kayak gimana, CI/CD mesti kayak gimana. Jadi developer cuma fokus develop app sama ngikutin kayak guideline yang udah di provide sama DevOps ini. Terus ketika upgrade yang dilakukan itu adalah biasanya si DevOps ini bakal communicate, kita butuh fitur ini dari Istio versi baru, terus ada tim yang butuh, yaudah kita mau upgrade nih. Kemarin yang dilakukan itu adalah upgrade-nya cluster, jadi nggak upgrade per service atau upgrade per namespace. Jadi yang dilakukan adalah kita communicate ke semua tim yang ada yang pakai Kubernetes cluster, dan kita bilang kita pengen update, yaudah kita update. Menariknya adalah kemarin ketemu masalah ketika update, saya juga kurang paham kenapa, karena itu di DevOps belakang yang ngerjain. Yang jelas ketika upgrade semua service lain aman yang nggak pakai Istio, tapi yang pakai Istio gak ada masalah. Jadi waktu itu yang dilakukan adalah rolling back ke versi sebelumnya. Dan setelah itu saya juga nggak tahu gimana caranya, kira tim DevOps tiba-tiba udah bilang dia udah ke-update. Permasalahannya waktu itu kita temukan dia sempat matiin, nggak tahu siapa matiin, tapi yang jelas traffic ke production waktu itu kurang lebih putus beberapa menit, kira-kira 5 menit. Dan habis itu di rollback, kemudian kayaknya tim DevOps ngelakuin beberapa upgrade kecil-kecilan gitu, akhirnya bisa. Terus saya kurang tahu detailnya kayak gimana, tapi kurang lebih kayak gitu sih. Itu kalau mau tahu lebih lanjut nanti ada orangnya namanya Agung Pratama. Cari aja. Kayaknya dia nonton YouTube-nya sekarang. Kita live stream di YouTube. Ya, lagi yang terakhir. Yang mana? Yang mana di belakang aja.
Mau nanya, apakah Istio support multiple domain, virtual host, terus kemudian gimana latent encrypt-nya, HTTPS, itu kan antar service oke lah, udah TLS. Kalau misalkan dari depan ingress-nya itu gimana manage HTTPS-nya. Terus kemudian masalah logging, kan kalau
Satu
itu kan
dulu Bang ya? Satu dulu ya. Saya lupa. Jadi gimana maintain ingress di depan HTTPS?
multiple domain.
Multiple domain.
Ya.
Multiple domain ini
Misalkan
saya
ada aplikasi V1,
Iya, iya.
V2, V3, misalkan by domain atau misalkan by path, misalkan domain / V1, V2.
Oh ya, kita kalau di POC kita yang ini kita nggak pakai multiple domain. Jadi semuanya kita cuma punya 2 domain dan itu 2 subdomain. Jadi cuma ada 1 domain. Jadi kayaknya saya juga nggak berani ngebahasnya gimana, takut salah. Karena kayaknya yang lebih paham tuh Agung Pratama namanya.
Masalah versioningnya itu V1, V2 atau V2 tapi di dalam portnya itu maksudnya pembedanya
Iya.
itu di dalam portnya.
Iya, kalau sekarang kita nggak ada ngebedain di level host, ngebedainnya di belakang aja. Jadi di DevOps Helm chart yang tadi ditunjukin itu cuma ada stable sama canary. Jadi kita cuma pakai 2 karena kebutuhannya sekarang cuma itu.
Jadi versioningnya itu di port ya?
Iya di port.
Terus kemudian HTTPS.
Kenapa? Oh, HTTPS setahu saya bisa di set di Ingress Gateway.
Di Istio-nya
Istio Gateway,
di depannya lagi.
Istio Gateway, di Istio Gateway. Ya, soalnya saya pernah lihat ada TLS di sana. Kalau seandainya saya nggak terlalu bisa menjawab pertanyaan DevOps, mohon maklum aja.
Terus satu lagi logging. Kalau misalkan tadi logging kan lebih parametrik ya, metrik response time segala macam. Apakah saya menanya itu logging seperti kayak access log atau error log gitu?
Oh,
Kan jadi lebih detail antara ada state-nya, ada address-nya.
Oh ya, jadi kita kalau logging kita pakai stack driver logging. Jadi di masing-masing apa sih namanya? Di masing-masing. Iya, benar. Jadi untuk khusus logging kita pakai stack driver karena stack driver udah cukup dengan untuk kebutuhan kita sekarang. Jadi kita nggak pakai yang lain. Jadi yang kita lakukan adalah karena kita pakai Go, terus pakai Logras. Jadi yang kita lakukan adalah kita pakai fluent formatter buat ngeformat lognya di level application supaya bisa nampilnya lebih structure di stack driver logging. Kayak gitu. Oke, sip. Udah ya, Bang? Udah.
Iya. Oke.
Udah. Stop juga ya.
Oke.
Siapa aja nanti sama si Iqbal.
Kita dari pembicara kedua kita, Imre lagi. Ini Imre mau bagi-bagi hadiah. Tiket ke Bali berdua Imre. Nggak mau deh. Baik loh orang. Oke, ada bagi-bagi hadiah. Itu di tangannya ada banyak voucher.
Bang.
Biar cepat. Jadi saya punya voucher 200.000